This protocol synthesizes precisely patterned static and reconfigurable particles of different shapes and sizes. First, design masks for the two-dimensional net that will eventually self-assemble to the desired patterned particles. Then, deposit the sacrificial and conducting layers onto a flat substrate. Fabricate the 2D precursors by patterning panels and hinges using photolithography, thin film deposition, and etching. Then, dissolve the sacrificial layer to release the 2D precursors from the substrate. Ultimately, the released 2D precursors are exposed to specific stimuli to trigger folding of the particles, ranging from the micrometer to the centimeter scale.
The implications of this technique extend towards the creation of miniaturized smart particles, including those that can do biopsies in hard-to-reach places in the body. Further, the method can be used with metals, semiconductors, and even polymers so that we can create capsules that could be important in drug delivery, especially since we can create them in non-spherical and multifunctional geometries.
The main advantage of this technique over existing methods like immersion polymerization or molding of particles is that this method transforms the accuracy and precision of planar lithography into three-dimensional patterning of particles with different shapes and sizes.
Visual demonstration of this method is critical as the patterning and self-folding steps are difficult to learn because they require both lithography and self-assembly skills. In this demonstration, we will fabricate